This is the third vodcast for Unit 5 on chemical names and formulas. In this vodcast, you're going to learn how to name using polyatomic ions as well as write formulas using them. In reference to the naming guidelines I gave you at the beginning of the vodcast 1, now we're going to start to name ternary ionic compounds which have 3 or more atoms involved in them, or 3 or more elements, I should say. Elements is a better word for it. So 3 or more elements involved. For this periodic table, you want to make sure you have your, for this vodcast, you want to make sure that you have your periodic table handy, as well as that golden sheet of nomenclature that was passed out to you. So, polyatomic ions, the definition of them is a group of atoms that stay together and have an overall charge and one name. So it's like naming a group that always hangs out together. Polyatomic ions usually end in the suffix "ate" or "ite." This is very important for you to know, okay? Because when I start mixing all the practice together at the end of the unit, that's going to help you figure out how to name it, or how to write the formula for it. If it has that "ate" ending or the "ite" ending, you know you're dealing with a polyatomic ion. So you want to check your golden sheet for these. Okay, here's an example of 2 polyatomic ions. You've got sulfate and sulfite. Notice sulfate is SO4 with a -2, and sulfite is SO3 with a -2. Usually the "ite" has 1 less oxygen than the "ate", but we're not worried about that, okay? I'm not requesting that you memorize them at this point. If you go on to take AP Chemistry, you will have to have those memorized. For your tests and your quizzes, I will provide you a abbreviated list of the polyatomic ions. You won't be able to use your golden sheet on tests and quizzes, but like I said, you will get a list of them that you're able to refer to. So you've got carbonate, CO3 2-, that's another polyatomic ion. Chromate, CrO4 2-. Dichromate has 2 of those chromiums in there. And then one of your very few positive polyatomic ions will be ammonium, NH4+, or +1. Just a few more: acetate, nitrate, nitrite. Again, there's that 1 less oxygen. Permanganate, and hydroxide, and cyanide. Okay? Now, you can see spelling's very important here. 1 letter change can completely change the meaning of the chemical formula. Look at the difference between nitrate and nitrite. All we did was change a vowel, but it makes a difference. So again, spelling is going to count for these. Okay, then you've got permanganate, and then hydroxide and cyanide. Notice these have the "ide" ending. These are the only 2 polyatomic ions that you have to worry about that have a different ending than "ate" or "ite." Usually when they end in "ide", they come from the periodic table, but these 2 are an exception. Okay, so naming with polyatomic ions. This is where the golden sheet comes in handy. Okay, we look first. CaNO3 inside parentheses and then a 2. Okay, we look first here at this. Ca. Is that a transition metal? Nope. It's just calcium. So I don't need a Roman numeral. And then I just look and I find this group on my golden sheet. Nitrate. Calcium nitrate. That's its name. Okay. For this next one, same process. Okay. I look here, I've got cobalt, CO. Is cobalt a transition metal? Yes, it is. So we're going to have to figure out a charge. For the meantime, we'll just put cobalt and then parentheses. And then I name my second polyatomic ion group here. Okay, find the name of that group. That group is called acetate. Look up the charge of acetate. Acetate has a charge of -1, and I have 2 of that group. So this is a -2. That means this one cobalt has to be a +2. So there's my Roman numeral. Cobalt 2 acetate. That's its name. You'll also notice in these, the first 2 examples, that I have parentheses. Okay, that's also a tip-off that you've got a polyatomic ion. Okay, but here in the third example, you'll see I don't always have parentheses, K2SO4, but I do have 3 or more different elements. I have potassium, sulfur, and oxygen. So see if you can pick this out here. The K is potassium, and then what's left is the SO4, and SO4 is called sulfate. Okay. No Roman numeral is needed because potassium is not a transition metal. Okay, how did I know the SO4 was the polyatomic ion? Well, most of the polyatomic ions come at the end because they're negatively charged, with the exception of ammonium, the NH4. So I know to look for it at the end. Also, it just comes with experience, okay? You need to become familiar with those polyatomic ions there on the golden sheet. Do the last one. We've got Fe, and then in parentheses Cn, and then a 2. So the parentheses tell us that's where our polyatomic ion is. And we look at Fe. Fe is iron. Is that a Roman numeral? I'm sorry, is that a transition metal? Yes. So it's going to need a Roman numeral. And then Cn is cyanide. Okay, so we figure out a Roman numeral. Cyanide has a charge of -1. There's 2 of them, so it has a -2. So my Fe has to be a +2 to cancel it out to 0. And I have iron 2 cyanide. Okay, pretty easy stuff. When I want to go and write the formulas with polyatomic ions, that takes just a little more care. Okay, so we've got aluminum. Aluminum is Al. If you look at your periodic table, it has a +3 charge. Next, I have acetate. It has that 8 ending. So I know acetate is a polyatomic ion. And I look it up on my golden sheet, and I find that it's C2H3O2 with a -1 charge. This comes as a group. I am going to need 3 of those groups to cancel out the +3 of the aluminum. So since the aluminum, I just need 1 of it, but because I need 3 of those groups, I need to put those groups in parentheses. Like that. That's the formula for aluminum acetate. I have to write it with parentheses. I can't write it like this without parentheses because then it looks like O23, and that doesn't work. And it's not correct to distribute the 3. I wouldn't write it like this. Okay, AlC6H9O6. That also would be incorrect. Okay, you just use the parentheses to show that you have multiple ones of that group. Okay, we do our next one here, sodium phosphate. Okay, you find sodium. Sodium is Na+. The phosphate, the 8 ending, says I have a polyatomic ion. I find phosphate. It's a -3. PO4 with a -3. So I am going to need 3 of those sodiums to give me a +3 to cancel out. So my formula is Na3PO4. Now notice, this time no parentheses. That's only because I only needed 1 of the PO4 group. I would not write it with parentheses. I wouldn't write it like this. Na3PO4 like that. Or even with the 1 out there. That would be written incorrectly. Okay, next one up, zinc hydroxide. Zinc is in the transition metals, but zinc is one of those ones that always has a +2 charge. So you need to remember that. And then I've got hydroxide. Now it has that "ide" ending, which would make you think it's just an element, but there's no hydroxygen element on the periodic table. Hydroxide's one of those exceptions. It's OH-. Now, I need 2 of those OH- to cancel out that zinc 2+. Again, I'm going to need parentheses. So Zn, I only need 1 zinc, and then I need parentheses like that to show 2 of the hydroxide groups. If I were to write it like this, ZnOH2, that would mean I have 1 oxygen and 2 hydrogens. When that's not the case, I need to have 2 oxygens and 2 hydrogens. The parentheses work just like parentheses in math class. The 2 gets distributed throughout. Okay, ammonium carbonate. Ammonium. There's no ammonium on the periodic table. Ammonium is one of those weird polyatomic ions. It is one of the only positively charged ones. So NH4+, and then carbonate, 8, means I'm looking for another polyatomic ion. You find carbonate on your golden sheet, CO3, 2-. Well, that means I'm going to need 2 of those ammonium groups, because they're +1 to cancel out the -2 of the carbonate. So parentheses, NH4, close the parentheses 2, and then CO3, like that. Okay, copper 2 nitrate. Almost to the end here. Copper 2, Cu +2. Okay, it's got that Roman numeral, so I know exactly what the charge is. And then it's nitrite. I made a mistake there. It's copper 2 nitrite. So you got to pay close attention to these. It has that "ite" ending, so NO2-. I'm going to need 2 of those 2- groups in order to cancel out the Cu +2. So I get Cu, parentheses, NO2, 2. Like that. That's copper 2 nitrite. Okay. So they take a little more practice, but really you're just going to have to get familiar with your polyatomic ions, the 8s and the ites, and then your 2 exceptions, hydroxide and cyanide, along with your weird positive one called ammonium, and then get the hang of using parentheses. But we're still following the same rules as we were in the very first podcast. The pluses and the minuses have to cancel out.